Right. Interestingly, we are looking at inhomogeneous equations. Inhomogeneous equation. And what did we say? We said so far we have an f of x that is equal to 0. We said it's an homogeneous equation. But in this case, we're looking at inhomogeneous. So let's write something quickly. You see, so far, all right, we have considered so far we have considered equations of the term. So far we have considered the equation of the term a the squared y over the x squared plus b the y over the x plus cy equals f of x. Sorry about that. What did we say? We said that if f of x is equal to 0, then am squared plus bm plus c is equal to 0. Given that, all right, given that m is equal to m1 and m is equal to m2 are the solutions, right? So this is the auxiliary equation here. We find m, and then the solutions, right, is in the general form. Let's put it that way. In the general form, y equals ae m1x plus be m2x. This is what we treated yesterday. We did a lot of this yesterday. We've touched some samples, we spanned across a lot of things, right? Now what I'm trying to say in this video, homogeneous equation, what we're trying to do here is to expose you to the fact that there are times when an equation f of x is not equal to 0. So let's expose you to that fact. When we say note that when we say that a the squared y over the x squared plus b the y over the x plus cy is equal to f of x, as long as f of x is not equal to 0. If f of x is not equal to 0, then we call this you see that? We call this an inhomogeneous, see that? Inhomogeneous equation. That's what we call it. An inhomogeneous equation. As long as you have that a the y over there is not, as long as f of x, right, is not equal to 0, that's the major thing there. We call it what? An inhomogeneous equation, right? And so the substitution y equals ae m1x plus be m2x would make the left hand side 0. It will make the left hand side 0. Is that okay? So that is what we are saying. Now the complete solution will be of a form, the complete solution will now take the form y is equal to ae m1x plus be m2x plus x. Did you see that? Now somebody will ask me what this x is. This x there is the extra function. X means the extra function. You see that? Yet to be found. That is what x means. Extra function yet to be found. And so y, which is equal to ae m1x1 plus be m2x, this guy is called the complementary function. In some textbook you see it as cf. All right, you see it as what? As cf. So it is good that we go through this rudiment. It is good that we go through these things so that when you are solving questions, you will know what you are dealing with, right? Now, y again, whenever you have y is equal to x, which is a function, of x, then this is called particular integral. It is called particular integral. Is that okay? All right. Okay. So let's get down to the business of the day. All right. Let's get down to the business of the day. Okay. Let's see an example. A very interesting example. Shall we? We'll look at an example quickly. All right. So always note, before we continue, always note, what are you noting? Always note that the particular integral is found by assuming the general form of the function. Always note that the particular integral is found by assuming the general form of the function on the right hand side. Did you see that now? So now let's solve a particular question and let's see how the detailing will go. Let's expose ourselves to some very interesting questions. So it says solve the squared y over the x squared minus 5 dy over the x plus 6y is equal to x squared. Did you see that now? We are saying that when f of x is not equal to 0, so look at it. In this particular example, you will discover that this is equal to x squared. So it is not called a homogeneous equation. Rather, this will be called, or this is known to be, an inhomogeneous, as the word implies. Inhomogeneous is right here, as long as f of x is not equal to 0. So we say it's an inhomogeneous equation. So let's solve it. So first of all, step one is to do what? Is to find, see that? Our step one is to find the complementary, look at it, complementary function, CF, is to find the complementary function. So for the sake of the video, I'll be calling it CF. So find the complementary function. That's solve, which means solve the left hand side, solve it to be equal to 0. Okay, so let's solve that. So in this case, let me find the auxiliary equation from here. Auxiliary equation is saying that this is m squared minus 5m minus plus 6, right? From here, here, and here. If you watch our previous video, you understand how we got auxiliary equations, right? Now, if we have this, we can break this down and say m minus 2, m minus 3 is equal to 0. This means that m is equal to 2 and m is equal to 3. You see that? So m can be 2, m can be 3. So it means that our complementary, whenever you have an inhomogeneous equation, you must always take note. Our complementary function will be that y is equal to, so what's the formula for getting complementary function? Is right here, right? Our complementary function will be what? Our complementary function CF, here. When you said AE m1 x1 plus BE m2 x2, right? Okay, so now we have y is equal to AE, m in this case is 2, so that's 2x plus BE, that's 3x. That's complementary function in this case now. Is that clear? That's our what? That's our complementary function. That's step one, right? This is step one. Now, our next question is to find out what step two will be, right? What is our step two? Our step two is to find, see that? Our step two is to find the particular integral is to find the particular integral, right? So to find the particular integral, we assume the general. So let's do this together. We assume the general form. We assume the general form of the right hand side, which is what? Which is the second degree function, which is a second degree function. There's a reason why I'm writing these things down, so that when you are reading, you understand what is happening. Is that clear? So let's do that quickly. Now, finding the particular integral is not difficult, right? It is not difficult. All you have to know is to take note of your left hand side and your right hand side. Now, your right hand side is telling you this, right? Your left hand side is telling you this. True or false? Okay, so if your right hand side is this, your left hand side is this, then what then is the particular integral, right? What then is the particular integral? So to find particular integral, what you need to do is to first see that you say let y equals cx squared plus dx plus e. You see that? Let y equals to what? Cx squared plus dx plus e. It means that the y over the x will be equal to 2cx plus d, right? And the squared y over the x squared is equal to 2c. As simple as that. Haven't compared, right? Haven't what? Compared. So we are comparing it. Is that clear now? So the y over the x is equal to cx plus d, 2cx plus d. The squared y over the x squared is equal to 2c. Alright, so some of you may be asking me, how was this possible and how was this possible? So let's do that so that you can get that clear. Let's differentiate. What is the y over the x? The y over the x, if you bring this down, this becomes 2cx plus d, right? Now let's redifferentiate. The squared y over the x squared, that will be 2c. Do you understand? If you redifferentiate this, you are going to have this. True or false? Now, if that's the case, now let's substitute these values. Substitute for the y over the x and the squared y over the x squared. Substitute them inside of this function. So let's do that quickly. So anywhere I see, so let me write the function out. The function says that the squared y, if you can remember very well, over the x squared minus 5 the y over the x plus 6y is equal to x squared, if you can remember clearly. So let me substitute back. The squared y over the x squared will be, this will be 2c. All I'm seeing here now is 2c minus 5 into the bracket of what is the y over the x. The y over the x is 2cx plus d plus 6 into bracket. What is y? Plus 6 into bracket. Remember that y itself is this, right? Y itself is this. So we have cx squared plus dx plus e all together. No, sorry, is equal to 2cx plus d. Yes, 2cx plus d. Yeah. So let me remove this. Sorry, 2cx plus d. That's all. All right. So it's equal to x squared. Do you understand? So all I did is just substitute this and for this. Do you understand? And for this also. So when you substitute that, what you'll be having is 2c, open brackets, you have 10cx minus 5d, yes, plus 6cx squared plus 6dx plus 6e is equal to x squared. So in the end, what you're going to be having is, okay, you're going to have bringing this forward, I'm going to have 6. I'm taking the biggest, so 6x squared plus 6d minus 10c x, collecting like terms, right? 2c minus 5d plus 6e is equal to x squared. Did you see that? So having said, now let's equate the coefficient of the power of x. So let's write equating the coefficient of the power of x. Equating the coefficient of the power of x, then we have for x squared. Now for x squared, we have 6c x squared is equal to x squared. So this cancels this. So we have 6c is equal to 1, right? It means that c is equal to 1 over 6. Now for that of x, we have 6d minus 10c is equal to 0. That's 0, right? Because there's no, what's it called? So 0, all right? But remember that what? C is 1 over 6, right? It means that we have 6d is equal to 10c, right? So you are saying that 6d is equal to 10 multiplied by 1 over 6, right? So d is what? What will be your d? Your d is 5 over 18, right? Your d is 5 over 18. So at this point, you have 6d is equal to 10 over 6 multiplied by this, this is d, 36d is equal to 10 divided by 36 back. So your d is 5 over 18. All right. So what's the next thing? Then for ct, which are the last variables there, right? For ct we have 2c minus 5d plus 6e is equal to 0. Definitely 6e is equal to 25 over 18 minus 2 over 6, which is 19 over 18. So our e here will be 19 over 108. So particular integral. So our complete general solution is that what? We have complementary function plus particular integral. So anytime we are solving a question that is inhomogeneous, like I said, this is where we started from. Anytime you are solving a question that is inhomogeneous, what you are going to do is, to get your general solution, you are going to do an addition of complementary function plus the particular integral. So where I wrote pi means particular integral, cf means complementary function. Is that clear? So your general solution will be y is equal to ae 2x plus be 3x plus, so what's the particular integral now? Our particular integral, I didn't finish that part. So particular integral here, right, is what? Is x squared over 6 plus 5x over 18 plus 19 over 108. Did you get that? So this is 19 over 108. Sorry, not 18. All right, not 18. So particular integral is that. All right. So if this is the case, then we can now do a complete addition and say x squared over 6 plus 5x over 18 plus 19 over 108. This is your final answer. So it's very important that we understand these inhomogeneous rather, so that it doesn't give us problems in the end of the day. Now let's look at a photo question. Let's look at the past question quickly. A photo past question where we have solve the squared y over the x squared minus 5 dy over dx plus 6y is equal to 24. How was this solved? Okay, so let's find the auxiliary equation here. The auxiliary equation is m squared minus 5m plus 6, right? Of course, we all know that this is minus 2m minus 3. Factorization happened here. Factorization. All right, factorization happened there, and we have it to be equal to 0. So it means that m is equal to 2 and m is equal to 3. So if we find the complementary function will now be ae 2x plus be 3x. That's the complementary function. Is that not? So now what's the next thing for us to do? We have to find the particular integral pi. Because f of x is equal to 24, so let's equate it. If f of x is equal to 24, we then assume that 24 is a constant, right? So y is equal to c. Okay, it means that the y over the x is equal to 0, because if you differentiate 24, is 0. In fact, if you find the squared y over the x squared of 0, it's still 0, right? So let's substitute this back into the original equation given to you, into this equation given to you. So all I'm simply saying is 0 minus 5 into bracket 0 plus 6c is equal to 24. Do you understand? So c is equal to 24 over 6, right? 24 over 6, which is what? 4. So our particular integral is that what? Y is equal to 4. So our general solution is very simple. Our general solution will now be y is equal to complementary function plus particular integral. So we have y is equal to ae 2x plus be 3x plus 4, so that you don't mistake it. This is the complementary function, this is the particular integral. Don't forget I said general solution is the same thing as you saying complementary function plus what? Particular integral. Did you see that? Particular integral. Is that clear now? So that is it. That is it. All right. So we hope that you understood what we did. If you have any other questions you want to ask, we are going to be more than happy to receive such questions. Is that clear? We'll be more than happy to receive such questions. All right. So again, thank you for having us. Thank you for listening. We love you. We appreciate you. We appreciate your efforts. All right. Before we go, let me add one more example to call it a day. Is that okay? Let's see if we can add one more example to call it a day. All right. Let's see. Let's look at it together. Okay. Photo pass question. The past question 2019 number 3. Okay, it says solve the squared y over the x squared minus 3 the y over the x plus 2y is equal to x squared. The squared y over the x squared minus 3 the y over the x plus 2y is equal to x squared. All right, so what do we do? Okay, so let's find step 1. Let's find the complementary function. This is called complementary function. So this is like saying m squared minus 3m plus 2. Okay, so what's the quadratics of this? That's two numbers that you can multiply to give you 2, that you can add to give you minus 3. We have m minus 1, we have m minus 2 is equal to 0, which means m is equal to 1 and m is equal to 2. Let's not forget that. So our y will now be aex plus be 2, okay, 1 2, okay, that's 2x, right? This is our complementary function cf, right? Now, if you continue on that same path, you now discover that your step two is to find the what? Find the particular integral, right? Finding the particular integral. How do you find the particular integral? You start from the right hand side. Where's the right hand side of this function? Right hand side says x squared, right? Okay, so x squared. So first of all, don't forget that particular integral is like saying y is equal to cx squared plus dx plus e. Please note this is very important. Very important. Very, very important. Now, let's differentiate this. If you differentiate this, we are going to have 2cx. Sorry, let me write that out in plain term. The y over the x of this is 2cx plus d, right? Now, the squared y over the x squared is 2c. Is that not? So it means that if we substitute this back into the equation, substitute back into the equation itself. Substitute back into the equation itself, which is this equation itself, this one. This is the equation given. So you'll be having something like 2c minus 3 into bracket 2cx plus d plus 2cx squared plus dx plus e is equal to x squared. So by the time you open brackets, you're going to have from here, let's open brackets from here, we have 2cx squared plus 2dx squared plus 2e. So we have 2d minus cx, yes, plus 2c minus 3d plus 2e is equal to x squared. So it means that 2c is equal to 1. That means c is equal to 1 over 2. Yes, c is equal to 1 over 2, right? And then if you say 2d, so we are comparing. How did I get this? Sorry, how did I get these numbers? 2cx, compare it to x squared. This cancels this, right? 1. So we have 2c is equal to 1. So divide by 2. C is equal to 1 over 2. Is that clear? Next we have 2d minus 6c is equal to 0. How did I get 0? Because after x squared here, this place is 0. Or you can say 0x. So I'm comparing it to that part there. Do you understand? So we're comparing it to so this is 0 and 2d minus 6 into brackets. Remember your c is 1 over 2. It's equal to 0. So 2d, 2 here 1, 2 here 3. Okay, minus 3 is equal to 0. 2d is equal to 3. And then your d is 3 over 2. Then lastly, we have 2c minus 3d plus 2e. If you're wondering where I got that part, this is where I got it from, right? So this is equal to 0. Then we now say 2e is equal to 3d minus 2c. And this is 9 over 2 minus 1, which is 7 over 2. So your e is 7 over 4. You see that? So it means that your particular integral is equal to y x squared over 2. Remember when we said particular integral? Look at it here. Particular integral is cx squared plus dx plus e. So we are multiplying it now. Cx squared, this is it. Because your c is what? What's your c? 1 over 2. So it's like you saying 1 over 2 times x squared. It will be x squared over 2, right? Plus 3x over 2 plus 7 over 4. So it's like you saying, since they're having, let's take the common, you can simply say 1 over 4 into brackets 2x squared plus 6x plus 7, right? Yeah. because if you do this, it will bring this back. True or false? Yes, true. All right. So at the end of the day, our general solution will be y is equal to aex plus be 2x plus 1 over 4 2x squared plus 6x plus 7. So this is the complementary function and this is the particular integral. See that? This is the answer. It's very, very simple and very, very straightforward. Is that not? Very, very simple and very, very straightforward. Mind you, this is when we are talking about inhomogeneous equations. Inhomogeneous equation. When f of x is not equal to 0. This is how to solve it. When f of x is not equal to 0. When f of x is not equal to 0. I hope you found this video interesting. I hope you found it enlightening. See you on the next one. My name is RIZZY. My phone number is +234 9058669385. In case you want to ask some questions, I'll be more than happy to reply you on WhatsApp. Is that okay? All right.